Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. The course is Statistical Methods 1 and the session is 23. So far we have dealt with various discrete distributions like binomial, Poisson, geometric and negative binomial distribution. In this in this session we are going to deal with hypergeometric distribution concept again by discussing the 3 important derivations mean, variance and moment generating function. Also, some examples will be worked out to understand the concept of hypergeometric distribution. What is it about hypergeometric distribution? When we discussed about binomial distribution, it is about the number of x number of successes out of n trials. The same thing with Poisson distribution, but when n is large and the probability of success p is very small and the lambda becomes n into p. The large number and a small quantity derives into a constant that is called lambda, that is with Poisson distribution. Geometric distribution is about repeating the trial until the first success happens, whereas negative binomial distribution is about repeating the trials till r successes are occurred. So, in continuation with that, we have hypergeometric distribution now in this session. If x represents the number of defectives found when n items are drawn without replacement from a lot of capital N items containing k defectives. Here we have to note down all the values, that is capital N represent the whole population lot and then a lot of n items, and a small n represents a part of capital N being taken from the lot of capital N items, but it is not being replaced, and k represents the number of defectives that lot of capital N items containing. Okay. So, obviously, when there are k defectives in capital N items, then n minus k will be non-defectives. So, what is about x? X is the number of defectives found out of n items drawn, x represents number of defectives found out of n items drawn. Okay. So, with this we proceed to write down the probability mass function of hypergeometric distribution. As discussed, this is also a discrete distribution and hence we will have the probability mass function. So, what is that? X represent number of defectives, n is small n is a sample consists from a population of capital N, and k are the defectives found in the population, and n minus k is non-defectives. Okay. So, we shall write the probability mass function of hypergeometric distribution. What is a probability mass function of hypergeometric distribution? Probability of x is equal to x is k c x n minus k c n minus x by n c n. It is easy to remember also this capital N C n, you first write in the denominator, okay, then adding and subtracting like k c x comes outside and n minus k c n minus k, it is a combination where your x will take the value, x is taking the value 0, 1, 2, 3 etc. up to minimum of n comma k, minimum of n comma k. If n is greater than k, then x will range from 0 to 3. If n is greater than k, then x values will be 0, 1, 2, 3 etc. up to only k. Okay. If n is smaller than k, then x is equal to 0, 1, 2, 3 etc. up to n. This is the probability mass function of hypergeometric distribution. Okay. Next we shall prove the mean and variance of hypergeometric distribution. Okay. So, first of all we will take the mean of hypergeometric distribution, which is equal to expectation of x. Expectation of x is summation x into p of x, is equal to summation x into p of x is k c x capital N minus k c n minus x by capital N c n. Expand this and whatever is not necessary with respect to the summation, some x ranges from 0 to minimum of n comma k, right. Whatever is not required, that we will take it outside, that 1 by n c n comes outside, okay. And then we will have summation x is equal to 0 to n comma k minimum values x into k is written as k factorial by k minus x factorial into x factorial into n minus k c n minus x. That gets cancelled 1 by n c n, summation x is equal to 0 to minimum of n comma k, and what is that here, x, k factorial I will write it as k into k minus 1 factorial by this is k minus 1 minus x minus 1, same as k minus x factorial itself, and x factorial I am writing it as x into x minus 1 factorial, right, and then n minus k c n minus x. Okay. All these were written in so that x gets cancelled and k comes outside, and the remaining is k minus 1 factorial, k minus 1 minus x minus 1 factorial, x minus 1 factorial. Okay. So, k comes outside, n c n, summation x is equal to 0 to n comma k, and you have a k minus 1 c x minus 1, and you have n minus k c n minus x. When you put k minus 1 is equal to k dash and x minus 1 as x dash, the whole expression becomes only for the summation, the whole expression becomes k by n c n summation ranging for whatever the values of x into k dash c x dash, and this becomes n minus k dash minus 1, right, c n minus x dash minus 1, right. Okay. And this becomes the whole expression when you expand and you apply the property of combinations, this becomes n minus 1 c n minus 1. Okay. So, I will write n c n as how to write n into n minus 1 factorial, n factorial is written like that, n minus n factorial into n minus 1 factorial. Actually, this is capital N factorial, n minus n factorial and small n factorial, right. And here usual format, this is n minus 1 factorial by again n minus n factorial, all these things are in the denominator, right, into n minus small n minus 1 factorial. So, what are the things which can be cancelled? N minus 1 factorial gets cancelled, n minus n factorial gets cancelled, and you have n minus 1 factorial gets cancelled, and you have only this is k small n by capital N. This is our mean. So, you have found out the mean as k small n by capital N. Next, we will find out the variance. Variance is v of x equal to expectation of x square minus expectation of x the whole square. Expectation of x we have just found, that is k small n by capital N, where we have to find out expectation of x square, and this can be written as expectation of x into x minus 1 plus x, right, and this is equal to, according to the expectation formula, this is summation x into x minus 1 plus x into P of x. I write this separately, separate the summation x into x minus 1 into P of x plus summation x into P of x. Okay. Summation x into x minus 1 into P of x, substitute for your P of x which is k c x n minus k c small n minus x by n c n plus, you need not write the summation and then verify it again, and you can just write the answer, this is k small n by capital N for this thing. Okay, for this thing it is written like this. And then in the usual procedure, take this n c n outside, k c x is written as k factorial by k minus x factorial into x factorial, write that x factorial as x into x minus 1 into x minus 2 factorial, so that x and x minus 1 gets cancelled. So, all these simplifications after being done along with k n capital N, you have only this k into k minus 1 into n minus 1 by n into capital N into n minus 1, plus I will just repeat this k n by capital N. This is expectation of x into x minus 1. Then we are going to find out variance. So, what is variance? Variance is v of x equals to expectation of x square minus expectation of x the whole square. So, writing the whole thing, k into k minus 1 into n minus 1 by capital N into n minus 1 minus k n by capital N whole square. Okay. And this gives you the answer n k into capital N minus k into capital N minus n by n square into n minus 1. This is variance. We have found out the mean and variance of hypergeometric distribution. Although the calculative is very lengthy, it is very important to derive the mean and variance and moment generating function for all the distributions. We shall discuss about some illustration. Okay. A taxi cab company has 12 ambassadors and 8 Fiats. So, totally there are 20 cars, that is a capital N is equal to 20. If 5 of these taxi cabs are in the workshop for repairs and an ambassador is likely to be in for repair as a Fiat, what is the probability that 3 of them are ambassadors and 2 of the cars are Fiats? Second question is at least 3 of them are ambassadors. Third question is all of the 5 are of the same make. Okay. So, we have to fix up the values of capital X, capital N, small n, then k value. So, these are the parameters required to do a problem in hypergeometric distribution. So, before proceeding into the solution of this problem, let us have a break. Before the break, let me tell you what was discussed, that is probability mass function of hypergeometric distribution was discussed along with the mean and variance. By finding the moment generating function, we have found out the moment generating function of hypergeometric distribution also. Let us have a break. Welcome after the break. Earlier to the break, we have seen the hypergeometric distribution, probability mass function of a hypergeometric distribution. We have found out mean and variance of hypergeometric distribution. Okay. So, we have been discussing this illustration. A taxi cab company has 12 ambassadors and 8 Fiats. So, we have to fix up the values of capital N, small k, and then x values. Okay. First of all, let us fix what is capital X stands for. Let capital X stands for number of ambassador cars. In the workshop, how many cars are there? Out of 5 cars. Okay. So, what is capital N? Capital N is 12 plus 8, total number of cars is equal to 20 cars are there, and K is the number of defectives found, that is defectives means successes, number of successes. So, K is equal to 12 and automatically small n will be number of cars in the workshop. So, n is equal to 5, n minus capital K is equal to 8. So, we have fixed up the values of x, capital N, K and then small n. We proceed further to find out the probability function of probabilities of this particular problem's description, right. So, first of all, let me write down what is a probability function of hypergeometric distribution. It is KCX n minus K C n minus x by divided by NCN. So, what is the first question? The first question is all of the 3 ambassador cars are in the workshop. What is the probability that 3 of the ambassador cars are in the workshop, right. So, we have to find out P of x is equal to 3. Except x, all the other values can be fixed, right. So, 12 C x, 8 C 5 minus x by 20 C 5. So, P of x is equal to 3 means it is 12 C 3, 8 C 5 minus 3 by 20 C 5, right. So, 12 C 3 into 8 C 2 by 20 C 5. By usual simplification with your calculator gives you the answer 0.397. The question is what is the probability 3 of them are ambassadors and 2 are fiats. 2 are fiats are obvious. Therefore, 3 of them are ambassadors we have found out where P of x is equal to 3. We are concerned about the number of ambassador cars in the workshop, that is what is x being fixed. Next, at least 3 of them are ambassadors. So, at least 3 of them are ambassadors means we have to find out the second question, at least 3 of them are ambassadors, right. So, P of probability that at least 3 of them are ambassadors. Which is equal to P of x greater than or equal to 3. How many cars are there in the workshop? Only 5 cars are there in the workshop. So, when you allow the value of x to go beyond 3, it is P of x is equal to 3 plus P of x is equal to 4 plus P of x is equal to 5. Okay. So, x is equal to 3, PMF written as 12 C x, right. So, 12 C 3, 8 C 5 minus 3 by 20 C 5 plus 12 C 4, 8 C 5 minus 4 by 20 C 5 plus 12 C 5, 8 C 5 minus 5 by 20 C 5. All these answers after careful calculations gives you the answer equal to 0.7038. Okay, this is second question, its answer. What is the third one? All of the cars in the workshop are either ambassadors or all of them are fiats. Third, probability that all of them are ambassadors or all of them are fiat. Okay. So, with respect to x value, x is representing number of ambassador cars in the workshop. When all of them are ambassador cars means x will take the value as 5. When all of them are Fiats, there are no ambassador cars, then x will take the value of 0. So, you have p of x is equal to 5 plus p of x is equal to 0. Okay. So, what is x is equal to 5? When you substitute in the this thing, it is 12c5 8c5 minus 5 by 20c5 plus 12c0 8c5 by 20c5. After careful calculation, the answer is 0.0547. Okay, consolidating, the first sum answer is 0.397, second one answer is 0.7038, third one 0.0547. So, another problem, similarly, a panel of 7 judges is to decide which of the two final contestants A and B will be declared the winner. So, there are totally 7 judges. A simple majority of the judges will determine the winner. As you know, the judges decision is final. So, when more judges judge the particular person with positive marks, then the particular person will win. So, a majority of the judges will determine the winner. Assume that 4 of the judges will vote for A and 3 will vote for B. We have to stick on to either A as a k values and either B as a k value. So, we will stick on to A. If we randomly select 3 of the judges and seek their verdict, what is the probability that majority of them will favor A? Okay. So, we have to fix up the values first of all. What is the values you are fixing up? X represents a number of judges favoring A, and then total number of judges is 7, right. So, capital N is equal to 7. How many judges are selected in random? 3 judges are selected in random. So, small n is equal to 3, and what is the k value? How many of them will vote for A? 4 of the judges. So, k is equal to 4. Probability mass function with respect to these values. So, p of x is equal to x is equal to kcx n minus kc n minus x by n c n. Again I will write down the x values, k values, because it is here. Capital N is 7, small n is 3 and k is equal to 4. Okay. So, we have P of first question, majority of the judges will vote for A. So, what is meant by majority out of 3? We have to divide for voting for A and voting for B separately. Out of 3 judges, voting for A will be 1.5, more than 1.5 will give you the majority, because 1.5 is half of the number of judges, right. 3 is the number of judges, 1.5 is the total number of half of the judges. For calculation, majority means you have to talk about 2 and 3 out of 3. Probability, a majority of 3 judges will vote in favor of A. This is equal to P of x greater than or equal to 2. As I already told you, this is definitely greater than or equal to 2, because more than 1.5. 1.5 is equally half, more than 1.5 will give the majority. P of x greater than or equal to 2. Substitute the values. Before that, let me substitute the values here. 4c x, 4c 3 minus x by capital N c n, 7 c 3. This is 7 minus 4, that is what is 3 c x. Okay. So, P of x greater than or equal to 2 is P of x is equal to 2 plus P of x is equal to 3. X equal to 2 gives you 4 c 2, 7 minus 4 is 3C3 minus x is 2 by 7C3 plus 4C3 3C3 minus 3 by 7C3. This gives you the answer 22 by 35. So, based on the discussions about the hypergeometric distribution, this exercise can be done on your own. Among the 120 applicants, so capital N is 120, whenever you see a number, if you immediately fix off its values and its representation as. Among the 120 applicants for a job, 80 are actually qualified. If 5 of the applicants are randomly selected for an in-depth interview, find the probability that only 2 of them will be qualified for the job using hypergeometric probability. They have mentioned this hypergeometric probability. It is about interview, we have to talk about only qualified people. Applicants we can't take into consideration. So, capital N is equal to 80 and 5 of the applicants are randomly selected. Randomly selected means small n is equal to 5 and probably only 2 of them will be qualified, okay, qualified for the job after the interview. So, k is equal to 2. You are asked to find out p of x is equal to 2, right. So, in this session we have dealt with hypergeometric distribution and also we have dealt with mean and variance. We have found out the moment generating function. So, the examples worked out will make you understand the hypergeometric distribution concept very clearly. Thank you.